Okay, 90 minutes. 90 minutes to glory. That is literally the exact amount of time standing between you right now and the grade you actually deserve. Welcome to the ultimate exam mastery explainer for Cambridge Computer Science. Today, we are targeting an absolute beast of a topic. It's one of the most high-stakes challenges across the entire syllabus. And I mean from the IGCSE codes 0417, 0478, 0983, 0984, and 2210, all the way up to the AS and A-level 9618 specification. We're talking about local area network hardware. Switches, servers, NICs, WNICs, WAPs, cables, bridges, repeaters, the whole shebang. This topic pops up in practically every single examination series. And yet, so many students completely blow it. Let me introduce you to two types of students. First, we have Alex. You probably know an Alex. Alex is our classic fact dumper. Alex goes into the exam and just overloads every single answer with raw computer science facts, but provides absolutely zero analysis. Then we have Sam. Sam is incredibly smart, probably knows the textbook inside and out, but Sam constantly rushes and completely misses the command word requirements. They are both losing massive points on real past paper questions, like those notoriously tricky Code 9713 network scenarios. So today we're taking a look at their flawed answers, analyzing the brutal red pen marks they receive, and I'm going to give you the exact step-by-step game plan to transform those mistakes into perfect scores. Let's get into it. So let's start with a massive reality check. Why do really smart students actually lose marks on LAN hardware? Well, the fundamental trap here is rote memorization. Memorizing the dictionary definition of a switch or a server or a wireless access point, that's a total trap. Students walk into that exam hall armed with basically flashcard knowledge, thinking that simply regurgitating what a network interface card does is going to magically secure them the marks. But here is the secret. Cambridge examiners are not looking for a human dictionary. They're looking for network architects. When Alex writes something like, "a switch connects devices," Alex gets exactly 1 mark and then hits a brick wall. Why? Because it completely lacks context. You have to realize that these exam questions are always contextualized within specific scenarios, like a hospital upgrading its network or a school expanding to a new building. If the question asks about that hospital, just saying fiber optic cables are fast isn't going to cut it. You are going to bleed marks unless you can strategically apply that hardware knowledge to the literal constraints of the problem they gave you. To pull you out of that rote memorization trap, we've developed what we call the Ultimate Exam Strategy Playbook. Here's the agenda for our explainer today. First, we'll hit core principles. Second, we'll dive into the procedural framework. Third, critical evaluation. And finally, we'll reveal actual examiner warnings. We are going straight from theoretical foundations right into insider examiner secrets. Starting with Section 1, Core Principles. We are stripping away all the fluff right now to see what Cambridge actually wants from you. The Cambridge syllabus emphatically states that top-performing students exhibit connected, conceptual understanding that transfers to unfamiliar contexts. Let me break down what that actually means. It comes down to analytical depth versus superficial breadth. Superficial breadth is what our student Alex does. Alex lists everything under the sun. A LAN needs a server to hold files, a switch to connect computers, a NIC to access the network, and cables to plug them all in. Okay, great. It's broad, but it's incredibly shallow. Now, compare that to analytical depth. Analytical depth is understanding the causal relationship between these devices. For example, instead of just defining a switch, a top-tier candidate explains that a switch populates a MAC address table by inspecting the source addresses of incoming data frames, and then it uses that exact table to forward packets only to the specific destination port. And then they'd explain that this eliminates the data collisions you'd normally see with a traditional hub, which therefore increases the overall bandwidth available to every user on the LAN. Do you see the difference there? One is basically a grocery list, the other is a beautiful demonstration of pure, connected system architecture. You have to move past simply knowing the names of the hardware and start explaining exactly how they manipulate the data traffic. And honestly, that brilliantly illustrates our next major point, cross-topic connections. If you ever sit down and read the principal examiner reports, which I highly recommend, by the way, they highlight a massive secret. Candidates who reference cross-topic connections achieve significantly higher marks. But what does that actually mean for you? It means you shouldn't be thinking of LAN hardware in a vacuum. When you write about a wireless network interface card, a WNIC, don't just say it catches radio waves. Integrate it with security. Mention how a WNIC's MAC address can be utilized by the wireless access point, the WAP, to implement MAC address filtering for robust network security. If you're discussing cables, don't just say copper versus fiber. Connect the concept of copper twisted pair cables versus fiber optic cables directly to the concepts of data transmission errors, signal attenuation, and electromagnetic interference. By showing the examiner that you understand how a simple hardware decision impacts network security and data integrity, you are elevating your answer from a basic IGCSE level fact dump to a true A-level masterclass in system integration. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's look at the PEAL framework. This is the absolute gold standard for structuring your answers. PEAL stands for Point, Evidence, Explanation, Link. When you see command words like analyze, evaluate, or discuss, you simply cannot just jot down bullet points. You have to structure your logic. Your point identifies the specific hardware, let's say a repeater. Your evidence provides the technical reality. A repeater regenerates digital signals. Your explanation details why this matters. It prevents attenuation over long cable runs. And your link ties it right back to the specific context of the question, therefore allowing the factory land to reach the warehouse building 150 meters away without any data loss. If our rushed student Sam had just used the PEAL framework, Sam wouldn't have lost those crucial assessment objective marks. Moving on to Section 2, the procedural framework. This is where we break down the technical methodology required to process those giant, scary exam questions. Did you know you can take algorithmic thinking, which you normally associate strictly with programming or pseudocode, and apply it directly to hardware problems? To get the top marks, you should be following this exact standardized sequence. Step 1. Identify elements. Read the scenario and explicitly list out the constraints. Is it a wireless environment? Does it require high security? Step 2. Apply principles. Select the right hardware based on those constraints. If it's a sprawling university campus, you're immediately identifying the need for bridges and fiber optic cables. Step 3. Execute analysis, with clear step-by-step working. Step 4. Verify results. Pause and ask yourself, did I actually answer the specific prompt they gave me, or am I just rambling? Step 5. Present in the appropriate format. When you approach a 10-mark question about setting up a LAN systematically, breaking it down into these exact procedural steps, you completely eliminate exam panic. And better yet, you guarantee that you are systematically hitting every single point hidden in the examiner's mark scheme. I really need you to burn this quote into your memory. Method marks can save you. Show you're working. Yes, even in a hardware question. So many students mistakenly believe that method marks only exist for mathematical algorithms or tracing through logic gates. That is completely false. When a question asks you to design a network topology and select appropriate hardware, explaining why you chose a bridge instead of a switch to separate two LAN segments is literally your working. If you explain that a bridge filters traffic to reduce collision domains between two distinct departments, even if you draw the network diagram slightly wrong at the end, the examiner can and will award you method marks for demonstrating a clear, logical, algorithmic thought process in your hardware selection. Show your logic every single time. Let's look at a live rewrite of Alex's raw, fact-overloaded answer. The prompt was about a company adding mobile laptops to their existing wired network. Here is what Alex wrote. The company needs a WAP. A WAP sends out Wi-Fi. Laptops have a WINC to connect. They also need a server to store files and cables to plug the WAP into the switch. Okay, that is just raw facts. There's no method, no analysis, no connection. Now listen to the structured, top-mark transformation using the PEAL method. To integrate the laptops, a wireless access point, WAP, must be installed. The WAP broadcasts the network signal, allowing the laptop's inherent WINCs to connect via radio frequencies. This WAP converts the wireless packets into wired Ethernet frames, which are then passed through copper cables to the central switch. This setup ensures the new mobile users can seamlessly access the central file server while maintaining the integrity of the existing wired infrastructure. Wow, do you hear the difference? This structure is exactly how you turn a measly 2-mark answer into a full 5-mark answer. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's get into Section 3, Critical Evaluation Skills. This right here is the true battleground for the A and A-star grades. You need to know that examiners absolutely love comparative analysis questions. They'll throw something at you like, compare the use of a bridge and a repeater in expanding a land. If you want maximum points, you cannot just list what a bridge does in one paragraph and then list what a repeater does in the next. You must explicitly state similarities and differences. For example, a similarity: both devices are used to extend the physical reach or capabilities of a network. But a difference: a repeater operates purely at the physical layer, simply regenerating all electrical signals to overcome attenuation, regardless of what the data payload actually is. A bridge, however, operates at the data link layer. It inspects the MAC addresses within the frames and intelligently decides whether to forward the traffic to the other side of the network segment. By utilizing comparative connectives like whereas or in contrast and providing hardcore technical evidence like layer operation or MAC address filtering, you lead the examiner to a fully justified conclusion. That is how you absolutely dominate evaluation questions.
Now let's take a concept usually reserved for coding, evaluating algorithm quality through time complexity, space complexity, and edge cases, and apply it directly to LAN hardware. You might be sitting there thinking, wait a minute, algorithms are for coding, not hardware. Wrong. Hardware runs on algorithms. A switch relies entirely on a routing algorithm to update and manage its MAC address table. When you're evaluating network performance, time complexity relates directly to latency. How fast can a switch look up a MAC address and forward the frame? Space complexity relates to the limited memory buffer inside the switch for holding that MAC address table. In edge cases, what happens during a broadcast storm when a network loop occurs? What happens when the switch's memory is completely maxed out? Understanding these parameters allows you to critically evaluate why a high-end enterprise switch is strictly required for a massive corporation, rather than just throwing in a basic, cheap, unmanaged switch. You are literally evaluating the embedded algorithms of the hardware.
Okay, it's time for an interactive workshop. I am going to give you a few seconds to scan the flawed sample paragraph on your screen and spot the exact sentence that is hemorrhaging marks. Ready? Here's the paragraph. The new school building needs a network. We will install a server because it is the most important computer. We will use switches to connect all the classroom PCs. Finally, we will use Cat6 cables because they are fast. Take a look, scan it. Did you find the flaw? Time's up. The sentence losing massive meta marks is, we will install a server because it is the most important computer. Why? Because it is entirely nonspecific and provides zero technical evidence. A top-tier student would immediately replace that with, we will install a dedicated file server to centralize student data storage, ensuring automated backups and centralized user authentication. Never, ever use vague terms like important or fast without immediate technical qualification.
Section 4. Essential Examiner Warnings. Pay close attention, because these are direct red flags pulled straight from the desks of Cambridge principal examiners.
Here are the top 3 traps literally destroying student grades every year. Trap number 1. Using the wrong formula or algorithm for the context. This happens when students apply wireless concepts to wired networks, or they completely confuse the advanced routing functions of a router with a simple LAN switch. Trap number 2. Forgetting boundary conditions and edge cases. In a hardware context, this means failing to consider the actual physical limits of the devices. For example, if you suggest using a single twisted pair copper cable to connect 2 buildings that are 300 meters apart, well, the boundary condition for that cable is roughly 100 meters before severe attenuation kicks in. If you don't explicitly mention adding a repeater to boost that signal, you lose the mark. Period. Trap number 3, non-specific answers. Writing something like, the WAP gives internet, instead of, the WAP acts as a bridge between the wireless devices and the wired LAN infrastructure. Examiners are absolutely ruthless about specific terminology. Don't give them a reason to dock you. To combat these mistakes, I want to introduce you to what I call the visual story method. This is an incredible memory hack to encode these complex network concepts into causal narratives, so you never have to rely on rote memorization again. Imagine the LAN as a busy, high-stakes corporate office building. The server? That's the highly secure underground archive room where all the files are strictly managed and backed up. The switch is the ultra-efficient mailroom sorting facility right in the lobby. It looks at every single envelope's destination MAC address and shoots it up the exact right pneumatic tube. The cables are the pneumatic tubes themselves, the physical pathways carrying the data. The wireless access point? That's the friendly bilingual receptionist who takes invisible radio requests from the guests' WNICs and translates them into physical envelopes for the mailroom. The bridge is the strict security checkpoint connecting the east wing to the west wing, only letting mail through if it actually belongs on the other side. And the repeater is just a guy with a megaphone relaying the message down a really, really long hallway so it doesn't fade out. By visualizing these causal relationships, your explanations in the exam will naturally flow with incredible analytical depth. Let's recap the complete computer science answering system. These are the 3 overarching rules that guarantee top marks when you execute this playbook. Rule 1, command word decoding. You must identify exactly what the question is asking. Are you defining, are you comparing, or are you evaluating?
Rule 2. Peel framework application. Never write a raw fact without evidence, explanation, and a link directly back to the specific scenario they gave you. Rule 3. The time management matrix. Remember, in Cambridge exams, roughly 1 mark equals 1 minute of writing. Do not spend 5 minutes writing a beautifully structured, elegant Peel paragraph for a basic 2-mark identify question about a Nic. Save and allocate your deep analytical energy for the 6-mark or 8-mark evaluation questions, where comparing a switch to a hub or debating fiber optic versus copper cables is actually required to get the grade.
Listen to this. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. So I leave you with this final, provocative question. Will you master the method or let the edge cases defeat you? Are you going to be like Alex, just dumping raw facts into the void, or will you step up and be the architect who structures every single answer for maximum points? Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.